Hi guys, hello, good evening. So I hope you are doing well, and I also hope that you have seen the last video on pointers. So in this session, I would mostly discuss about this dynamic memory allocation. But once again, yes, we would also cover some topics of pointers. So this is kind of a related thing. That is why I say that video, the last video, is basically a pre-requirement before this live session. So if you have watched that video, that is fine. If you haven't watched that, no issue. Attend this. You would find it comfortable. But after this session, you can get back to that video and you can watch it. I'll put the description, like I'll put that link for the video in the description, so you can find it there. Basically, what I'll do in this session is, as it is mentioned in the title, we would cover dynamic memory allocation. So there are two kinds of memory allocation, right? One is the memory which is allocated during compile time, that we call it as static memory allocation, and one that is allocated during runtime, that is called as dynamic memory allocation. So the memory which is allocated during compile time, that is called as static memory allocation. Not the memory, but that allocation is known as static memory allocation, and memory when allocated during runtime, that is known as dynamic memory allocation. So how do we dynamically allocate memory? Okay, so we'll do one thing. Let's first talk about the static memory allocation a bit, that we already know, but we'll just quick brush up thing. So let's go to there and we'll here take some example. So whenever we write this, let's say int x equal to 10. So what happens, guys? As I've already said this thing, so whenever this thing would be executed, or let's say this is the statement is read, so a memory would be allocated. Okay, there would be some address associated with it. Let's say 101, name of the location would be x, and value 10 would be stored there. So this memory would be allocated at compile time. That is why it is known as static memory allocation. Okay, so this is known as static memory allocation, the memory which is the allocation which is done at the compile time, or static memory allocation, that is known as static memory allocation. So what is then dynamic memory? Which we allocate during runtime when the program is executing, and if the memory is allocated at that time, then we say that there is dynamic memory allocation. Okay, so let's see this. Let's take a quick example here. So to create memory at runtime, we would need the help of pointer. Okay, we cannot take help of a normal variable and expect that the memory would be allocated during during runtime. No, as soon as you write a variable int y, so memory for this y would be allocated. However, like whatever size this int will take, let's say 4 bytes, so that 4 bytes would be allocated at compile time. So this would not wait for runtime to allocate the memory. So in order to allocate memory at runtime, you have to take the help of pointers. So let's say I have a pointer p. So p is a pointer to integer. Okay, so I want to allocate a memory for one integer. I want to store an integer value there. Okay, so how do we do that? How do we allocate memory at runtime? So there are various functions, guys. You might have heard about this malloc or malloc. Normally we say malloc, or you can say also malloc, memory allocation, memory alloc. Okay, then there is this calloc or calloc, contiguous alloc. Okay, then we also have realloc. I'll talk about them in detail. Realloc certainly is used for a different purpose, not to allocate memory, as you like, as it is very clear from the name itself, it is reallocation. Okay, so once you allocate memory, if you want to change that memory allocated, then you go for this realloc. Okay, fine. So these are the functions which we would require, or these functions would be involved in dynamic memory allocation, or allocating memory dynamically. So let's talk about malloc, because that one is the most preferred function to use. So if you want to create memory for one integer, so what you would say, you'll write p equal to, you'll write here int star malloc, and how much byte you want. So I just want a memory that would store an integer value. So size of int, that is what I'm saying. Size of int is, let's say, 4 bytes. So it would allocate a memory of 4 bytes. Okay, so it will allocate a memory of 4 bytes where I can store some data. How to store the data? Now you see p is pointing here. Okay, P is, let's say this address is 201, so P value is 201. It is holding address of that memory location. And if you want to store value in that dynamically allocated memory, so you would access it through pointer, because that is the only access. There is no variable here, right? So P here is pointer, which is actually pointing to that location. So through P we would access that memory location. So you'll write star P equal to 20. If you write star P equal to 20, so 20 would be stored and the memory location 201. Okay, so this is how we allocate memory dynamically, and this is how we access that memory. So the question now is, why have we written this int star? Okay, I hope this is clear up to this. Please let me know in the comment if there is any doubt up to this. Okay, I will continue to move on with the detail, but if you have doubt, you can ask in the comments so that I would clear. So yeah, so the question now here is, why we have written here in star. So this is kind of a typecasting, right? As you know already, this is typecasting. We have typecasted this malloc to integer, kind of like to a pointer to integer. Why we have done that? Okay, we have done that because return type of default return type of malloc is actually void star. I'll come to this void star later, but let me just finish this right now. The default return type of malloc is void star, and as we are here trying to allocate a memory for one integer, we need a pointer to integer. As see, here we want to allocate a memory to store one integer value. So the kind of memory allocated, I need it to be an address of a integer variable. Okay, got it? That is why I am typecasting it into int star. From void star to int star, I am typecasting. I'll come to this, the void star and all in detail. Then it will be very clear. For the time being, just know that okay, we have to typecast this malloc. Not only this malloc, even if you use calloc, you have to typecast this, guys. Okay, got it? So P equal instant malloc size of int. So it would allocate a memory for one integer. Then you can easily store the value here. Like here 20 is stored in memory location 201. Got it? So as I said that malloc is most preferred function for dynamic memory allocation. What about calloc? What about the C alloc? What is the difference between this malloc and calloc? Why do we like go for malloc and not for calloc? So let's have a quick comparison between this malloc and calloc, and we'll be good with this. So let's have this. So what is the difference? As I said already, malloc syntax is okay. We would typecast it, some typecasting. Let's say int star for here for now for the time being. Okay, so if you see the previous example, we have written p equal int star malloc. Okay, let's not take so much space between it. I'll just do here int star malloc. Okay, so here we have, as we had as we need to like create only, what is that, memory for only one integer. So that is why we have directly written size of int, right? Let's say I want to create 5 blocks of memory kind of thing, not exactly blocks. So let's say I want to create a memory for 5 integers, an array you can basically say. So 0 1 2 3 4. Okay, so you want to store this kind of this 20 30 40 50 kind of this. So how would you do this? So you would pass argument here malloc like this, n into what is n here? N is nothing but number of elements you want, number of blocks you want to create, n into and size of, let's say int, because I want to store 5 integer variables. So I would say 5 into size of int. Okay, let's say I want to store 10 elements, 10 integers. I will write 10 into size of int. Got it? Size of int would be 4 into 10 40. So 40 bytes would be allocated. So we can store 10 elements. Got it? So that is how it is done, guys. That is how it is done. But the same thing if you want to do with calloc, so you would write in this way. So instead of malloc, we'll use calloc. And here calloc takes 2 arguments. First is the number of blocks you want. Second, the size of each block. Okay. So malloc takes only one argument, but calloc takes 2 arguments. If you need only one block, just put 1 in place of n, and it would just create one block of size of 4 byte if you are given size of int. Okay. So in malloc we have to write n into size of int, but in calloc we have to pass two argument n comma size of int. This is one of the difference, the number of argument between malloc and calloc. One more thing, there is a difference between this malloc and calloc is calloc will allocate a memory. Let's say I have created only one calloc, one comma size of, let's say, int. So what it would do is it will allocate a memory, fine. Let's say address is 305, for example. It would, this calloc would initialize the memory with 0. Got it? It will allocate a memory and will initialize it with 0. But that is not done in the case of malloc. So if you create or if you allocate memory with malloc, so it would allocate a memory, let's say 409 for example, but it will not assign any value. It would be garbage value. Okay, but the thing is malloc is faster than calloc, and we normally don't want to have some initial value when we are allocating memory dynamically. So we just call call malloc, and it would just allocate some memory, and we as per our requirement we store some value there after doing some operation. Okay, so malloc is preferred as it is faster compared to calloc, and normally we don't need to have initial value for the allocated memory. Got it? So if you are interested, you can also have a look on memset. That is a function memset. Okay, if you want to allocate, like if you want to assign some value, let's say you don't know about calloc, for example, or let's say you want to actually go with malloc because it is faster. So you can actually create memory with malloc and use another function called memset, memory set. It would actually set a value to the particular location. If you want to set some value, you can use the memset to do it. Okay, if you're curious enough, you can have a look on memset, or let's say I would try to come up with a another video for this memset and malloc. Okay, got it? So this is the difference or comparison between calloc and malloc. This is how it does. So one thing is clear from here, we will go with malloc. Got it? As it is faster compared to calloc. And moreover, we normally don't want to have any initial value after allocating memory dynamically. Okay, so we go for malloc. Got it? And what about realloc? Realloc, as I said already, if you have already allocated memory by using malloc or calloc, and if you want to reallocate it, let's say you have created only 5 blocks, and now you realize that okay, 5 blocks would not be enough, and you need to have more blocks. Let's say 5 more blocks. So total 10 blocks you want. In that case, you would use this realloc. Got it? Okay. So you would use this. So kind of this syntax, you'll write p equal to insta realloc, the pointer name, okay, the number of okay, pointer name, and the total, the new size. You'll write, let's say 5 blocks were all there. So now you would create 10 blocks. So 10 into size of int. So it would reallocate the memory assigned to P with now with 10 blocks. It was earlier 5 blocks. Now it would be 10 blocks. So this is how you can use this realloc to actually reallocate a previously allocated memory. Got it? So this is calloc, malloc, and realloc, or you can say malloc, calloc, and realloc. Got it? Okay, fine. So this is about this dynamic memory allocation, like how do we allocate memory dynamically or at runtime. But let's get into more depth about this, like what happens, what is the difference between this static memory allocation and dynamic memory allocation. So what happens there? So let's get into this. Got it? I hope you understood up to this. If you have any doubt, please let me know in the comment section. I will get into the next section, that is what happens behind the scene, like what happens exactly in the memory side when we use static memory allocation and dynamic memory allocation. So we'll have a quick comparison between this. In order to have that comparison, we need to have a quick discussion on the memory areas, guys. Okay, so the first thing before getting into the comparison is the memory areas we have actually. Might have heard this, might have seen this already. So you might have heard about, not the entire memory area I will take. I'll just take the memory area which are concerned to this discussion. If you want the complete thing, okay, what I'll do is I'll come up with an different video. Like I'll put this memset thing and also this complete memory area thing there in that video. For the timing, I'll just cover only what is required for our discussion here. Okay, got it? Fine. So I would discuss this two things. One is heap memory area and this stack memory area. So one is the heap and one is stack. I think you know about this, or you might have heard about this heap memory area and stack memory area. Okay, so all the statically allocated memory would be allocated here. Okay, I'll just write here static memory allocation. Got it? And all the dynamically allocated memory would be allocated from heap memory area. There are certain other memory area also, but I'm concerned about this two right now. I'll come up with another video actually to cover all the memory areas. For the timing, let's get into this. So all the dynamically allocated memory would be allocated from heap memory area. So there is a heap memory area, and there is let's say this is heap, and let's say this is stack. Got it? So all the statically allocated memory would be allocated here in stack, and all the dynamically allocated memory would be allocated from heap memory area. So heap is like it is designated for the dynamic memory allocation, and stack is designated for this static memory allocation. So see this. What happens when we allocate memory dynamically? What happens, and when we like allocate memory statically? What happens? So as I said, when you write int x equal to 10, okay, let's say this is inside a block, int x equal to 10. So memory would be allocated, right? Whose name is x and value would be 10. So this is static memory allocation, right? So this memory would be allocated in stack memory area. Okay, but you write whenever you write this whenever you use this malloc or calloc, let's say of int size of int. So what will happen? So this will allocate a memory for one integer. Fine, there is no name for this memory because we have not assigned any variable here. So only a pointer would be pointing. If you would write p equal to, okay, if you write int star p equal to malloc this, obviously there would be a typecasting operator here. Let's say int star. So P would just be referring to this, okay, but there is no name for this memory location as this. Here, this memory location has a name, that is X, but here this memory location has no name. So this is unnamed memory location. There would be some address. Let's say this is 101 and this can be 202 maybe. Let's just take it as this. So this memory location would be allocated. This memory location would be allocated in a area which is heap memory area. So what is the difference between these two memory area? The difference here is, see, when you come out of this block, so X has been created inside this block. So once you come out of this block, this memory would be automatically deleted. Okay. So it is kind of a local variable, right? Int X is your local variable in the scope. So when you come out of the scope of the block, then that variable, that memory would be reallocated automatically. Okay. But if you have allocated memory using dynamic memory allocation, when you come out of the block, scope of the block, this memory will not be deleted or deallocated. It would still be there, maybe holding some values there. Okay, it would still be there. It will not be automatically deleted. Obviously, when your program ends, every memory associated with the program would be deleted automatically. But let's say we have four functions in your program, and in one of the function you have allocated memory, dynamic allocated memory using dynamic allocation, and one is local. Let's say, okay, we'll take this example. Let's go with the same example. Let's say whatever I have allocated memory here. Okay, just give me a second. Let's say this is the block of a function, some function here. Okay, just ignore the syntax here. Just assume that okay, there is a function fun, and inside it we have allocated memory using static memory allocation, and also we have allocated memory using dynamic memory allocation. So when you go out of scope of this block, the memory associated with X would be deleted automatically because that is static memory allocation, or yeah, static memory allocation. We know that automatic variables are deleted automatically, right? Okay, so when you go out of the scope of the block, the memory allocated by this malloc will not be deleted. It would still be there. When your program gets over, okay, that would be deleted. So this is the difference. Anyway, when your program gets over, everything would be deleted. The memory associated with the program would be deleted. But I'm talking about individual scope of a function. Let's say in a function like this, we have created two things. When you come out of the scope of this function, memory associated with X would be deleted, but the memory allocated by this malloc would not be deleted automatically. When your program ends, that would be deleted. Okay, got it? Yeah, Chandrasekhar, it's not my birthday, but anyway, thank you. Fine. So let's get into a different section now. I hope this point is clear to you guys. Let me know in the comment if you have any doubt on this. So this was just a quick comparison between this memory allocated statically and memory allocated dynamically. What happens exactly? So the simple thing we got to know here is when we have allocated dynamically, but when we have allocated memory dynamically, and when we are coming out of the scope of the block, that memory will not be reallocated automatically, but the statically allocated memory would be deleted automatically when we come out of the scope of the block where it is created. Okay, so so with this, let's move to the next section, that is your leak memory leak. So what do you mean by memory leak? Okay, you can post your answer in the comment section. Okay, meanwhile I'll just carry forward the session. We'll talk about the concept about memory leak. This is a very important topic, guys. Memory leak, I have seen many people have asked question on this, so please be very attentive and understand what is this. Okay, so see this. As I said here, if inside the block I have created a memory dynamically, let's say malloc size of int, right? So inside this block I have. So as I said, in heap memory area, this memory would be allocated. Okay, this memory would be allocated. Let's say address is yeah, let's take 101. I just normally take 101 everywhere. Got it? So this is where the memory is allocated, and this malloc is returning that address of that memory location to P. Basically, maybe I have left this point. Pardon me. So just keep this yeah as a note. So malloc will allocate a memory, and it would return the address of that memory, which would be stored in this P. So P is a pointer. It is, yeah, pointer. So which will store the address of that location, and we say that P is pointing to that memory location. Got it? Okay. Okay. This is what we need to know or keep in mind. If malloc would not be able to allocate the memory for any reason, let's say the memory is not available, sufficient memory is not available. In that case, malloc will return null, and null would be stored in P. That means P would not be pointing or referring to any memory location. Got it? So if you want to check whether the memory was allocated or not, just after this you can check here. If P is equal to null, obviously memory has not been allocated. So you can just have a message and quit, or yeah, exit from this function. Got it? So you can check it. If P is equal to null, then you can say memory not allocated. So you can just have a return statement. Got it? Right. So then if P is not null, that means memory has been allocated and P must be pointing to that memory location. So you can just do some operation. Let's say I will write star P equal to 10. So this 10 would be stored here. Star star of P is 101, star of 101. So value there. I'll store 10 there. So 10 would be stored in that memory location. Got it? So here I said one thing, guys. I said when you come out of the scope of the block, this memory would not be deleted, right? This memory allocated, dynamically allocated memory would not be deallocated automatically. So what is the issue there? The issue here is, okay, before telling the solution or telling this thing, I would ask you one question here. Can you say me where this P is allocated? Where this P? So this dynamically allocated memory we have created, that is created in heap memory area. Fine. Where is P allocated? Whether P is allocated in heap memory area, that is the question. That is the most important question here in this concept of memory leak. That thing you need to have in your mind, keep in your mind, because I've seen many people have doing mistake. And this concept, if you are very clear, then linked list would be a game to play. You just have to play around pointers to implement linked list. So you need to understand this concept. If you want to be like comfortable with linked list, then this concept is very much important for you. Let's see this, guys. Where P is actually allocated in which memory area, whether it is heap or it is in stack. That is the important question. P here, as I already said, P is a normal variable, local variable you have created inside the scope of the block. So memory for P would be allocated in stack memory area. So P is in stack memory area and the allocated memory using malloc would be created in heap memory area, and P is just referring to that memory location. Got it? P is the only access to the memory which has been allocated dynamically here. Okay. Now when you are coming out of the scope of the block, as P is a local variable or kind of the memory is allocated statically, that would be deleted automatically. If P is deleted, then there is no access to the dynamically allocated memory like this one. There is no access to this memory now, because P was the only access to the memory location. We can use this memory location only through P. Now P has been deleted. Why? Because we have come out of the scope of the block. Now we don't have any access to that memory, the dynamically allocated memory. So that memory will not be deallocated automatically, as we have already discussed this characteristic. And also it is containing some value. So when you allocate memory dynamically and forget to deallocate it, this situation occurs, and this situation is known as memory leak. This situation here is known as memory leak, guys. So when you forget to deallocate the dynamically allocated memory, what will happen? The memory would still be there. It would be like yeah, holding some value, and you cannot access it. You have lost the access, you cannot access it again. That is known as memory leak. Obviously, see, when your program ends, memory would be deallocated automatically anyway, but till you are in the program, that memory would be still be like that memory would still be there and holding some value, and you cannot use it. That is known as memory leak. So in order to avoid this situation of memory leak, what we have to do, we have to deallocate that memory before you go out of the scope of the block. If you don't want to use it further, if you don't need it further, then deallocate it before you go out of the block, otherwise memory leak will occur. So in order to deallocate, what we need to write, there is a function called free. So use free p. So this would deallocate the memory. Okay, let me get back to it. Okay, I'll just remove this one, just a moment. So in stack now, so P was there, P was holding this address 101. Yeah, 101, and we say that P is pointing to referring to that memory location. So before coming out of the scope of the block, we have deallocated this memory which has been allocated dynamically by using this free function, free P. It will deallocate the memory. Now P is referring to that memory location. See, the memory has been deallocated, but the memory location will not go anywhere, right? That has been deallocated. That's all. So it would contain now some garbage value, but P is still pointing to the memory location because there is a memory location whose address is 101 in your system. Got it? So P would be pointing to that memory location, but anyway that memory is not allocated right now. It would store some garbage value. It is unallocated memory, so it has been added already to the free memory area in heap pool. Got it? Okay. Now when you come out of the scope of the block, P would be again deleted. P would be deleted. Okay, P would be deleted. Now it is fine. So now memory leak has not been occurred. This thing you need to keep in mind, guys. Okay, got it? So this is the concept which is very important, memory leak concept. And this concept we it is involved in your linked list. You have to understand this if you want to be very comfortable with this linked list. Okay, so I hope this concept is clear. Let me know in the comment section if you have any issue, guys. Got it? I'll move on to the next thing, just a short thing here. I want to discuss about this. See this. So P is pointing to the memory location, right? And we have used this free. Okay. Let's say we have not come out of the scope of the block. Now, what I'm trying to do here is, let's say I'm trying to print the value of star P. We have already deallocated the memory, the dynamic memory allocated, but now I want to print the value pointed by P. P is still pointing to memory location 101, right? Okay. So what is the thing here? Can we do this? Would it give us some value or will it give some error? Okay, please mention your answer in the comments. Meanwhile, I'll just discuss this. So this will certainly not give you error, rather it would give some garbage value, guys. As I said, the memory location 101 is not going anywhere. The memory location is still there. It is just unallocated, deallocated. It is holding some garbage value now. Okay, so it would give some garbage value. But this situation now, this P, basically this P, it is now known as dangling pointer. You might have heard this term, guys. Most of the time they ask this question, what is dangling pointer? So to be very simple, you would just say, if a pointer is pointing or referring to a memory location which has been already deallocated, then that pointer would be called as dangling pointer. I will not say that these are the types of pointer, rather I would say these are the situation involved with this pointer. So in this situation, this pointer would be called as dangling pointer. Okay, you can also say this is kind of an error situation. We should not actually access that memory location after deallocating it, but we can. That doesn't mean we should access. We should not. Okay, but we can, as we have done here. We printed it, we got garbage value, but this should not be done. We should not access it. Okay, so this situation here, if P is still pointing to a memory location which has been deallocated already, then in this kind of situation, this pointer would be known as dangling pointer. Got it? There are certain other pointers also, guys. Like we have what is that? Wild pointer. What is wild pointer? Wild pointer is nothing but unallocated pointers are known as wild pointer. Let me clear this out and I'll go to the next, like discussing this wild pointer and some other few kinds of pointer. So I hope this is clear, this memory concept, dangling pointer. Let me know in the comment section if there is any issue on this. Okay, I'll have to recover that. So see this. Yeah, so we are talking about wild pointer, and I said unallocated pointers are known as wild pointer. So it is just like this. If you write int star p, this pointer is just created and it is not referring to anyone, like no address has been assigned to it. So this is known as wild pointer. Okay, people normally get confused between this dangling and wild. I don't know why, but it is very clear. It is very different and it is very clear. Wild means if the pointer is not referring to any memory location, if nothing has been assigned to this, that is wild pointer. Okay, dangling means if a pointer is referring to a memory location which has been already deallocated, that is dangling. And what about null pointer? I think this is simple. Null pointer you can answer easily, right? Null pointer. So let's say we have a pointer, let's say q. If you assign null to this, then it would become like this q is now a null pointer. Okay, these are, you can say, error situation. Like if you now try to print star q, it would kind of give some error, like null point exception kind of this. Okay, you cannot access anything through null. Q is null, so you cannot have some value. It is not referring to any memory location. Okay, so this is error. So there's a kind of various situation involved with this pointers, guys. So I hope this thing is clear. This dynamic memory allocation, what is memory leak, what is this dangling pointer, what is this null pointer, wild pointer. Okay, So one more thing which I feel like discussing here is that void pointer. Okay, remember during the start of this session, I had told something about this void star. I said the default return type of malloc is void star, and we converted or we typecasted it into int star. So what is this void star? In C, actually, this void is used as like two ways. One is it can be used for nothing, it can be used for anything. So what is that nothing? So data type. When you mention like when argument is void, that means there is no argument. It will not take it would take any it would take no argument, or it will not take any argument. If you put argument as void in the place of arguments, if you put void, no, it is not. It suggests that the function is not taking any argument. Got it? That means nothing. If you talk about anything, how is void used as anything? That is this concept, pointers, void pointers. Okay, this is anything actually. So I should not write this here. This should be anything. One is nothing, void is used as nothing, also it is used as anything. Nothing when it we mention as data types, and anything when we use it as a pointer to void. So void star. Okay, so this void star is known as generic pointer, guys. Why it is known as generic pointer? It is known as generic pointer because this void star, this pointer void star, it can be typecasted into any kind of pointers. First of all, like you can typecast it to int star, you can typecast it into cast star, you can typecast it into float star, any kind of this, or let's say yeah, float star, any kind of pointer. You can typecast that into any kind of pointer. Also, you can store any kind of pointer in void star. I mean to say, let's say uh, this is void star p, okay, and you have a variable, let's say int x equal to 10. So you can store address of x in p. P is not a pointer to integer. You can say void pointer. P is a pointer to void actually, and you are storing this address of x in P. It can be done. Yeah, it would give some warning to you maybe, but it can be done. There is no problem. So generic, it is known as generic pointer because it can handle any kind of pointer. Also, it can be typecasted into any kind of pointer. Got it? But the problem here would be like, what exactly do you mean by void pointer? So it is kind of a memory, but there is no proper boundary kind of thing. So you're not sure about the exact kind of address you are storing. Whether you are storing address of an integer, whether you are storing address of a character, whether you are storing address of a floating point number. So that is not very clear here. If you store address of integer in void or integer of character in void, so you'll not get any clarity here. Okay, that is why when we try to print the value stored in that memory location, we always typecast it. So you'll say okay, we can just write star p. Okay, we should not actually do this way. We should not do. Actually, we have to typecast this p into int star. Then we would print the value. So first of all, we have to typecast this p into int star. Then we can print the value pointing to that memory location. Value stored in that memory location. Got it? So this is your void star, guys, generic pointer. Got it? So I hope this is clear, guys, to you. Like this, all the things related or revolving around these pointers. Some more thing, I'll try to put up a video on that, like the different memory areas and also about this memory set, and all. Okay. So let me clear this. I hope you understood this well. Okay. So let me know if you have any queries regarding to this, guys. I'll just wait for you for some time. So you can put your queries regarding this topic in the comment section, and I would love to address all those questions of yours. Okay. So we have discussed, first of all, we have discussed about this dynamic memory allocation. We started with that, like how, what are the various ways through which we can allocate memory, like malloc, calloc, realloc, and all. Okay. So then we just compared this malloc and calloc. What is the comparison? Like we discussed this malloc and calloc. Got it? So and we conclude that using malloc would be better as it is faster. Using malloc would be faster. It is faster. So we would prefer malloc. Calloc only benefit is Calloc would allocate a memory and it would store initial value. Like it will allocate memory and initialize with some value. Normally we don't need that, so we go for malloc. And if you really want to have a value in that allocated memory, then you can always go for memset. If you are curious enough, you can have a search on it, or I will put a video on the same. Okay, don't worry about that. Got it. One more thing is, then we discuss about this realloc. Okay, if you have already allocated memory and you want to change it, like you realize that okay, it is not sufficient, you have to increase it, or let's say you want to decrease it, we go for this realloc. We had discussed that. And then we discuss various aspects of this related to this dynamically allocated memory. Like we discuss about what happens, the comparison between the static memory allocated and dynamic memory allocated. Also we discuss about this memory leak concept. With that we discussed this dangling pointer, generic pointer, wild pointer, null pointer. So kind of this is whole of this pointer thing, guys. If you would be very comfortable with this, if you are very clear with this, then this linked list thing would be very easy for you, because I'm planning to come forward with linked list in upcoming sessions. So you please uh, get through this video, this one and the previous one on pointers. Okay, I will make sure I'll put the link of that video, or let's say I'll put the link for the entire data structure playlist in this description after this video ends, so you can go back there and watch it. Okay, this will be very important as go on, like this concept. See, if you understand pointers very well, you'll do linked list very well. If you understand linked list very well, then you can like use that to implement stack, queue, tree, all those stuff. Got it. And also there are various operations in linked list also. If you understand single linked list, then you will understand better the double linked list and circular linked list, and so on. So it is like related. These are the foundation things, guys. That is why I started with this thing. So let's build our foundation first. Let's make our foundation strong. Then we would use that to upgrade ourselves. Okay. That is why I say kill the bias, upskill with key to CS. Got it. So guys, so this is what I had for this session. I hope you enjoyed this session. Please subscribe the channel and share among your friends, guys. If you found this helpful, share among your friends. Maybe there is someone there who need this thing to be like mentored, so he would get help, he or she would get help. Okay, and those who are preparing for preparation, this campus preparation placement, so this would surely help them out. Okay, so I'll keep on doing this, guys, for your betterment. I would try to give more topics. Like I said, I'm planning to bring this linked list from in upcoming sessions, and furthermore topics I would also bring in. Don't worry about that. So we'll slowly unroll everything. So then, guys, so take care. Bye. We'll meet in the next live session.